Hello, seventh grade. Next lesson for math. We're going to be combining a few of the next couple lessons. So this is going to be lessons 3 and 4. Next time you'll do lessons 5 and 6. Okay, so we're looking at identifying proportional and non-proportional relationships in tables. So last week we looked at unit rates or unit prices and then equivalent ratios a little bit with finding proportions, whether the whether the ratios form a proportion. So now we're going to be looking at those in tables. So first one here, we're looking at hours worked to pay in dollars. So if you worked 1 hour, you got paid $8. You worked 2 hours, got paid $16. 3 hours, $24, and so on. So we're looking at like 2 to 16, 1 to 8. So then our question at the bottom are these ratios proportional? So are these ratios proportional? How do we find that out? So if we take our pay divided by hours worked, so 8 divided by 1, we get 8. If we take 16 divided by 2, we get 8. 24 divided by 3, we get 8, and we go through and check the whole table, and we know that they are proportional because you always get 8. That's how you know, okay? So then here's our answer. Yes, how do you know 1 times 8? Or you can do the multiplication way, 1 times 8, 2 times 8. Either way works. Okay, so these ones you're going to work on your own. So when you're ready to see the answer, hit play. You're determining whether or not the ratios are proportional. So this one we're looking at time in hours to snowfall in inches. So we have 2 hours, there's 10 inches of snowfall. 6 hours, 12 inches of snowfall. 8 hours, 16, and so on. So if we take 10 divided by 2, we get 5. 12 divided by 6, we get 2. So we know already that they are not the same. So this one is not proportional. We know that already. Now let's look at this one. So we have number of days worked to cost in dollars. So 6 days, $2, 9 days, $3, 24 days, $8, and 3 days, $1. So if we take 6 over here, or we take 2, let's take 2 divided by 6, we get 1/3. If we take 3 divided by 9, we get 1/3. 8 divided by 24, we get 1/3. And 1 divided by 3, we get 1/3. So we find out the first one, no, the ratios are not equivalent. Second one, yes, they are, because you can divide them all and get 1/3. So you can also create your own table for the listed numbers to then determine if the ratios are proportional or answer other questions. So we have decided to walk in a long distance race. There are 2 teams that you can join. Team A walks at a constant rate of 2.5 miles per hour. Team B walks 4 miles the first hour, then 2 miles per hour after that. Create a table that shows the distances walked for the first 6 hours. Okay, so we'll go to the next one and see what our table starts with. So we know that Team A walked 2.5 miles for the first hour, and B walked 4 miles the first hour. So let's fill in Team A first. We know this one's easier because we know that they walk 2.5 miles every hour. So we just have to add each time. So we get 5, 7.5, 10, 12.5, and 15. This one we have to add 2 to each one. So they walked 4 miles the first time, but then after 2 hours they had only walked 6, 8, 10, and so on. Okay, so we created our table that shows the distances for the first 6 hours. Now we can answer questions about the table. So for which team is distance proportional to time? So which one has a proportional table? So let's go back and look. So we take 1 times 2.5, we get 2.5. 2 times 2.5, we get 5. 3 times 2.5, we get 7.5, and so on. So we would know that this one is proportional. We take 1 times 4, we get 4. 2 times 4, oh, that's not 8, 6. So we know that the first one, Team A's table, is proportional, not Team B. Let's look at our next question. Now, at what distance would it be better to be on Team B than Team A? Okay, so let's look back. So up until 4 hours at 10 miles, Team B is walking more in less time. But now it looks like after 5 hours, Team A had walked more. So if less than 10 miles, you want to be on Team B because they're covering more distance in less time. But if it's more than that, Team A is actually going to end up covering more distance. Okay, so let's look at our last question. If the members on each team walked for 10 hours, how far would each member walk on each team? So we'll go back again to our chart. So we know that this one, they're just walking 2.5 miles an hour. So we can take 2.5 times 10 and we get 25 miles per hour. This one, so if we add, we'll keep track. So we're at 6. So we had 2, we're going to be at 16 for 7 hours. Add 2 more, we're at 18 for 8 hours. 2 more is 20 for 9 hours. And we had 2 more, it's going to be 22 miles for 10 hours for Team B. Okay, so Team A is 25, Team B is 22. So you're going to use this one here to make your own chart. So Bella types at a constant rate of 42 words per minute is the number of words she can type proportional to the number of minutes she types. Find her words per minute for 1, 2, 3, and 6 minutes. So pause, hit play when you're ready to look at the answer. So if we make her chart, we have 1, 2, 3, and 6. She types 42 minutes, 42 words in 1 minute, 84 words in 2, 126 in 3, and 252 in 6. Yes, her relationship is proportional because the rate is constant. We can see a constant rate. And then we know that if we multiply the number of minutes, for example, 2 times 42, we get the correct number of words. So your assignment is going to be working on an IXL skill 7-K.7, identifying proportional relationships from tables. So if you need more help, let me know. With this skill, the goal again is a SMART score of 100, but I do not want you spending more than half an hour on this one skill. So if you get to 30 minutes, just stop, and that's where you're at for this skill, okay? I don't want you working on it more, especially when if you're not getting other things done. If you're confused about that, let me know.